There's the wonder of sunset at evening, the wonder as sunrise we see, but the wonder of wonders that fills my soul is the wonder that God loves me. The wonder of it all, the wonder of it all, just to think that God loves me. Oh, the wonder of it all, the wonder of it all, just to think that God loves me. There's the wonder of springtime and harvest, the sky, the stars, the sun. But the wonder of wonders that thrills my soul is the wonder that's only begun. Oh, the wonder of it all, the wonder of it all, just to think that God loves me. If you know it, sing along. Oh, the wonder of it all, the wonder of it all, just to think that God loves me.
That was a perfect song, George, and so beautiful and so touching. And it just goes right along with our message today. Our speaker that I have the privilege of introducing is Randy Hodges, who was a professor of science and astronomy at William Jessup University. And every time he comes and speaks to us, I always think, oh man, I wish I could have been in his class. Because, and to think we have a Christian man teaching science is just too exciting. So Randy and his wife, Carolyn, they run the library. If any of you frequent the library, you can thank Randy and Carolyn for organizing that and making that possible for us. And also, something you may not know about Randy and Carolyn is they love to camp. Now, I don't mean they have a $100,000 RV that they travel around in with TV and electric blankets and stove. They have a tent. And they travel extensively, not just like one night, but they go all over the United States and they enjoy the country and the universe that God created firsthand. And so without anything else, make Randy Hodges welcome.
The word for the day is awesome. We hear awesome misused all the time. People say, I had an awesome hamburger for lunch, or I saw an awesome show on TV, or an awesome movie, or read an awesome book. But awesome means so much more than that. The idea that awe is something that God put in us that's more than just up here. It's visceral. It comes from down here. It's emotional. And I define awe. Give me the second slide there if we can. Okay. The way I define awe for my students is experientially. And most of you have experienced what I'm going to explain now. Have any of you ever been to the Grand Canyon? I hope all of you have. And what do people do when they first walk up to the edge of the Grand Canyon? Say, this is the edge. They're back here, and they go, and that's awe. And that's what I did, and I'm guessing that's what you guys did too, because it is truly awesome. It's a visceral reaction. It isn't just in your head. It's an emotional reaction to how amazing the Grand Canyon is. And the people who made Yosemite did something similar. When my parents were growing up, or when my dad was growing up, his parents took him to Yosemite every weekend or every summer for his whole life. So by the time I came around, they were tired of it. So I never got to go to Yosemite until I was an adult. And we were living in Hanford, California. I was teaching in the high school there. And we drove up from Fresno through the southern entrance. And the southern entrance, Highway 41, comes into the Yosemite Valley through a long tunnel. And you guys have probably been through this tunnel. And the people in Yosemite realized that as you come out of this tunnel, there's El Capitan, and there is Half Dome and Glacier Point, and you come out of there, and you just, and I'm betting if they didn't put a parking lot right there, they'd have a lot of crashes because people would just react to that in an amazing way. And that is, again, how I would define awesome. Awesome is something that isn't just, wow, that's cool. It's something that just affects you and the word is visceral, meaning in your guts. You feel it. You feel that amazing, wow, this is something really, really special. And one of the things I love about astronomy is the awesomeness of God's creation. And actually, I got to experience that again for the first time since I was 9 years old. 9 days ago, I got cataract surgery, and the world's a lot brighter for me. And Sunday night, for the first time since then, the smoke cleared, and I went out, and I just almost fell over because I realized what I've been missing all these years. The stars and everything was right there. And what we're going to talk about today is a little bit of history, a little bit of theory, a variety of things having to do with it. Actually, go ahead and give me the next slide. This is just the legal or the dictionary. Extremely impressive or daunting, inspiring great admiration, apprehension, or fear. And there's some fear involved in awesomeness too sometimes. Okay, the next slide is the biblical one. The Hebrew word is used many times in the Psalms is being translated as fear, feared, feareth, afraid, reverence, usually in reference to a man fearing something of God. And so anyway, awesome is a concept that we as Christians should be used to, and we probably shouldn't misuse it. We probably shouldn't use it for trivial things. We probably should use it in its truest sense for what it is. And when I think of this whole issue, I think about how does God communicate with us? God, give me the next slide. And how does God talk to us? Okay, obviously, he talks to us through his word, and we love that. He talks to us through the Holy Spirit. He talks to us through godly counsel. I often hear God speaking through Lowell or John or one of you. And hopefully you hear a little bit of that from me. And that's one of the ways God speaks to us is through other godly people, through our conscience. God sometimes says, you probably shouldn't do that. And that's God speaking to me. But another way that he talks to us is through nature. And go ahead and give me the next slide. And this is one of my favorite verses. This is Romans 1:20. It says, for since the creation of the world, God's invisible qualities, his eternal power and divine nature have been clearly seen, being understood from what has been made. So when we look at nature, we see God. We see what God has created, and we can tell what God is like by what he created. Well, what did he create? He created an immense universe. And what we're going to talk about today is a little bit of the history of how we've come to understand what we call the cosmos, or what we call the universe. And what we understand as the universe today is infinitesimally larger than we used to think it was. It is so huge. I've used this illustration that, and I don't have a quarter, but if I had a quarter and set it on the ground and said, that's how big our solar system is compared to the Milky Way, this compared to the United States. How big is a quarter compared to the United States? Not very big. And yet our solar system is so big that just in the last couple of years, we finally sent a rocket ship outside of it. But all the exploration we've ever done is inside that little quarter. And yet we've barely begun to touch it. And the universe is giant. Why would God have created it? It seems very, very oversized. It would be like sometimes when we travel, we see people who have these giant homes. And then you find out that it's two people who live in that. And you think, wow, why do they need a home that big? And the universe is kind of like that. You know, why do we need a universe that's so much huger than we are? And the answer to that is God saying, hey, this is who I am. I'm not this'll do kind of God. It's an extravagant God. An extravagant God that makes things so big and so magnificent that we really can't even comprehend how big and how powerful and how wonderfully made they are. Okay, so let's go back to a little bit of history. I think the next slide takes us, actually these are a couple of scriptures that I pulled out that are pretty good. Jeremiah 10:12, it is he who made the earth by his power, who established the world by his wisdom, and by his understanding he stretched out the heavens. Okay, the next one is Isaiah. Thus saith the Lord, who created the heavens and stretched them out, who spread out the earth and what comes from it, who gives breath to the people on it and spirit to those who walk in it. Okay, and then next, the heavens declare the glory of God and the skies proclaim the work of his hands. Okay, and then the next one. And this one I like because a lot of times people say the Bible doesn't get it. The Bible presents, a lot of people think that the Bible presents a flat earth. In reality, in the Bible, it presents the earth as being a circle. We knew that it was a sphere. And frankly, the idea of a flat earth came along way, way later after biblical times. This is he who sits above the circle of the earth, and its inhabitants are like grasshoppers who stretch out the heavens like a curtain and spreads them out like a tent to dwell in. So God did a good stuff. And anyway, he made it for us to understand who he is. When we look at God, he isn't some little God who doesn't have much power. He's a God that has tremendous power. And I hope by the end of what we talk about today, you'll begin to understand that God is transcendent from nature. He's above nature. He isn't part of nature. He isn't part of creation. He is the creator. And that's a very big distinction. Okay, so next slide. Okay, we're going to go back to the ancient Greeks. And we're going to talk about evolution of how we understood what the universe is like. And the Greeks, and frankly, pretty much everybody at the time, thought that the stars revolved around the earth and that they weren't very far away, that they were in a sphere, like a bubble surrounding earth, and those spheres move at different speeds. All the stars moved at a certain speed. There was a sphere that had Mercury in it that moved pretty fast. There was a sphere that had Jupiter in it that moved slower. And each of the planets had their own spheres. The sun had a sphere, the moon had a sphere. And Ptolemy created this model. And it was revolutionary because up until then, people didn't really create models of how things work. And you guys have all seen models of the human heart or of a atom, and that helps you to understand how something works. Well, Ptolemy is the first one who created a model of the universe. He was wrong, but what's surprising is this was amazingly accurate. Okay, so next slide. And with this model, people were able to predict the movements of the sun and the moon. They were able to eclipse solar eclipses and lunar eclipses. And this remained the model that people used for 1,700 years. And the thought was, there are the stars right above us, just maybe 100 miles or 50 miles above us. And when you go out at night, you don't really have a good sense of distances. The moon and Jupiter look like they're equidistant apart, but they're not. You know, the moon is literally right in front of our eyes, and Jupiter is out there 500 feet. And but we don't have that sense of direction because everything is so far. We don't really understand how far it is. And by the way, the Greeks did some amazing stuff. They even calculated, they knew that the earth was round, and their model said that, and they calculated the diameter of the earth. And it turned out to be within 1% of the value we know today. So pretty good for for before Christ. Okay, then came along, next slide, a man named Copernicus. And you guys have heard of Copernicus. And Copernicus says, I think it makes more sense if we put the sun in the middle and put us rotating around the sun. And that first model was called the geocentric model, geo meaning earth, the centered, and the heliocentric is Copernicus's model, helio meaning sun. So the sun-centered model is what Copernicus came up with. And basically it's what you see there. And guess what? They didn't accept it. You know why? It wasn't any more accurate than Ptolemy's model. So Ptolemy's model, even though it wasn't based on truth, turned out to be more accurate in predicting things like eclipses and the movement of the stars and the planets than Copernicus. Now it turns out Copernicus was right except in one aspect. Copernicus said, well, God made it. He was definitely a Christian. And if God made it, he would have made everything perfect. So the orbits had to be perfectly circular. Because we know now that they're not perfectly circular, but that assumption, which he refused to even accept the idea that it wasn't perfectly circular, led to inaccuracies in his model. So it took a while for people to recognize that. Let's go ahead and get to the next one. And one of the things that happened is they hired a guy named Johannes Kepler, and this is a little bit after Copernicus, to try to prove that Copernicus was right. And Kepler started studying the actual movements and doing it mathematically. He was a genius. And he said, I just can't make it work. He refused to fudge the figures to make it work. And he said, but wait a minute. If we assume that these orbits aren't circular, but they're an oval, it does work. And Kepler came up with what we call the rules of orbital motion that we still use today. When we SpaceX sends something up, they use Kepler's laws to direct that spaceship and to help it find things. And so Kepler made a huge contribution, and all of a sudden, instead of the Earth being here with spheres very, very close to us, we ended up with a solar system-sized universe. And that's what they believed, that the universe was there and the stars were just outside the orbit of the planets surrounding the Earth. And then along came a man named Galileo. And Galileo was amazing. Galileo said, up until Galileo's time, for the most part, people sat around in a room and said, I think this is how it works. And somebody else would say, no, I think this is how it works. And they logicked it out. Well, Galileo said, well, let's check it out. Let's do an experiment. Let's do observations and see if we can find what's what. And Galileo, you're all familiar with his famous experiment at the Leaning Tower. Okay, what did he do at the Leaning Tower? He dropped two balls. They were the same size but different weights. Okay, and logic says what? Which ball would hit first? The heaviest one, right? He said, well, that makes sense, but let's try it. So he dropped it, and guess what happened? They both hit at the same time, because gravity has the same pull no matter how much something weighs. And he said, wow, maybe I need to do experiments on a lot of stuff. And Galileo was the first one who took a telescope. He didn't invent the telescope, but what he did is he took this thing that sailors were using and said, what happens if we point it up here? And he started looking at things. He looked at the moon. And the orthodoxy of the Catholic Church at the time said, the moon is a perfect sphere. And he looked at it and says, whoa, there's mountains, and there's craters, and there's dark spots, and there's all kinds of stuff on it. He looked at the sun, and what he saw through the sun was spots on the sun. And the Catholic Church says, nope, no spots on the sun. God made it, it's got to be perfect. And he looked at Jupiter, and one of his most famous things that he observed is when he looked at Jupiter, he saw 4 moons that we now call the Galilean moons that orbit Jupiter, and he said, wow, those follow Kepler's laws. Kepler must be right. That's a microcosm. When we see Jupiter, we're seeing a microcosm, a model of what the whole solar system is like. And so he got excommunicated, of course. And but he still made one of the most amazing things. And at that point, we had a better understanding of what our solar system was and what our universe was. They still didn't understand how far the stars were, although he did. One of the things, and there's something called parallax, and you guys can all experience parallax. If you hold your finger in front of your eye and close one eye, and then close the other eye, you notice your finger tends to jump from one side to the other. Well, that's called parallax. And if something is relatively close to us and you observe it from this position and then you wait 6 months till the Earth has gone around in its orbit, 196 million miles, 186 million miles, it should shift in regard to the other stars. And he couldn't observe that. He couldn't find that. Well, Galileo said, maybe it's because things are so far away that we just can't measure it. He says, maybe there really is parallax, but we just don't have the ability to see it. If something's far enough away, it doesn't seem to move. And so that's how he dismissed the parallax argument. And so anyway, we've come to believe him at this point and find out that he was right in most things. Next person was somebody who's considered to be, and this is actually his drawings on the right of the moons of Jupiter. And the moons of Jupiter are really cool. Have any of you ever seen them? They're pretty amazing. From night to night, they move. The closest one moves around Jupiter every 2 days, and then 4 days, and then 8 days, and 16 days. And so they're in different positions, and these were his positions he saw the moons in. And sometimes he could see all 4. Sometimes one would be in front of or behind the planet. And then on the left there are actually 2 pictures taken through a modern telescope of Jupiter's moons. And I don't know if those are ones I took, but they're very easily visible even in binoculars. So it's pretty cool to look at those. So that was Galileo. Okay, so Newton. And Newton is considered to be the greatest scientist of all times by a lot of people. Pretty amazing guy. He was a very strong Christian. He realized that he didn't have the tools, the mathematical tools, to understand what he was trying to understand. So he invented calculus. And he invented calculus one time when there was a plague in England and he was confined to his home. So think about, what have you guys done during COVID? And if you invent a new branch of mathematics? Anyway, and he came up with the rules that help us understand the universe. His first one was called the law of universal gravitation. Universal gravitation says everything in the universe pulls on everything else. And it depends on how close you are and how massive those things are. Something really massive, really close to you is going to pull really hard. Something small, a long ways away, is still going to pull on you, but not very much. And so every particle in the whole universe is pulling on every other particle. And he came up with that. He came up with the laws of motion for each action, there's an equal and opposite reaction. And he has 3 laws there. He refined Kepler's laws. He was the first one to take light and send it through a prism. And when you send it through a prism, it gets separated into its different colors. And he realized light is made of all these other colors, the colors of the rainbow, Roy-Jabib. My students always love that. And you guys know what Roy-Jabib is? Red, orange, yellow, green, blue, indigo, violet. And the opposite is Vibgyor. And anyway, he was the first one that discovered that, and he discovered that if you burn something or heat something up and send it through the prism, it makes distinct lines. And those distinct lines can be recognized as unique chemistry, that each one of those represents hydrogen and helium and oxygen and carbon. And you can recognize what it is without actually even touching it by the light that's emitted from it. And he discovered that by sending it through a prism. And he also invented the type of telescope that pretty much we still use today. I still own a Newtonian telescope, which is a pretty decent telescope. Okay, so anyway, that's Newton. And then came along this guy. And this guy isn't famous for what he wanted to be famous for. He's famous for what he wanted to avoid. And his name is Charles Messier. And Messier was a comet hunter. If you're an astronomer and you want to be famous, what do you need to do? Discover a comet. And he was determined to discover comets. And actually, he did discover a few. But when he would look out in the sky, he'd look and he'd say, oh, that's a fuzzy spot. That's the same fuzzy spot that was there last week. That's not a comet. And he discovered all these spots in the sky that, at first he would think was a comet, and then realized, no, it's not a comet. And so he made a catalog of all these things in the sky that could be mistaken for comets, but aren't. So his Messier list, 110 of the brightest objects in the night sky, are things that he wanted to avoid. And today we know of those as being some pretty exciting things. And actually, these next slides, I believe, are some slides that I took with my telescope at home. It's a little 10-inch scope in Placerville, pointed at the sky, and I take pictures with it. And these are some of those objects. And this first one, and I'll kind of move to the side here so you guys can see, is what they call a globular cluster. It's a group of maybe 10,000 to 1 million stars that are all in a small little ball. And he discovered that. And of course, he didn't see them in the detail even I'm seeing them in today. He saw them as just fuzzy patches. But as we looked at those fuzzy patches, we discovered all kinds of neat stuff. And these things orbit the Milky Way. They're like satellites orbiting the Milky Way and passing through the Milky Way. So they're pretty cool. Okay, the next one. Okay, this one is called the Trifid Nebula. And it's actually really cool because it has 3 different kinds of nebula. And nebula is just glowing gas. And the red is hydrogen, the blue is helium, and the black is dust that obscures part of it. So you're actually seeing 3 different kinds of nebulas there. And this is pointed towards the center of the Milky Way. And that was one of the things that he discovered. That picture, by the way, was taken on one of our trips. We were in Indiana at a place called Turkey Run, which is a marvelous state park in Indiana. And we were out looking at the Neowise comet, and after it set, we started looking at other stuff, and I took that picture. So anyway, it's a marvelous place and marvelous cool. So next one. This is another one called the Lagoon Nebula, and it's again a glowing gas. And this is cool because it's a star nursery. New stars are being formed here. So stars go through lifetimes just like we do. When they're young, they tend to be blue and hot. And as they go through life, they cool down and they evolve. Well, this is a place where new stars are being formed. And it's called the Lagoon Nebula. So next. And that was taken at a place called Potter's Pond at 9,500 feet in the Wasatch Mountains above Provo, Utah. And again, that was on one of our trips. And this is and we'll come back to this later because it's important. This is actually not part of our galaxy. This is another galaxy called the Whirlpool Galaxy. And what's cool about that is it has two, and should have brought my laser pointer. You see the smaller galaxy is being pulled into the bigger galaxy. And over a period of time, eventually those two will merge. But that's a separate total galaxy. But in Messier's time, the thought was those are just part of our galaxy, that they're not beyond our galaxy. They're not something that's beyond what we understand. So next, this is called the Orion Nebula. This is the brightest nebula in the sky. It's part of the Orion constellation, visible to the naked eye in winter. If you know where to look, you'll look at it and say, that star's kind of fuzzy. I should be able to see that now. I couldn't a couple weeks ago. But anyway, this is taken with some detail. And again, that's a star nursery. And that's the closest star nursery to Earth, about 500 light years away. And let me describe a light year for you. Light is very, very fast. Light can travel to the moon and back in 1.5 seconds. Okay, so pretty quick. And, no, actually 3 seconds. 1.5 there, 1.5 back. And it takes 8 minutes to get to the sun. It goes around the Earth 7 times in 1 second. And if you were to take a spaceship going the speed of light, traveling for a year, that would be about 3 trillion miles. That's a number that doesn't make any sense to you, but it's a long, long time. We call that a light year. It's how far light would travel in 1 year. And this is about 500 light years from Earth, and that's the closest star nursery to us. So anyway, that's a pretty cool and one of my favorite objects to photograph. Okay, so next. And this is actually M1. This is the first thing he discovered. And this interesting story behind this is called the Crab Nebula. And the Crab Nebula was first discovered, or actually it wasn't discovered, in the year 1054, Chinese astronomers noticed a supernova in the sky. They didn't know it was a supernova. All they knew it was a very, very bright star, bright enough to be seen in the daylight. And they wrote down where they found it in the sky. And modern astronomers look at that and they see this. And this is the remnant of that explosion that happened in the year 1054. It's called the Crab Nebula. And what it is gas expanding out from this supernova explosion. So anyway, that's the Crab Nebula. Okay, so next. And this is another, and this is not a great photo, but this is another galaxy called the Triangulum Galaxy. And you can see the arms of it spiraling out from the bright center there. And this is probably 100 billion stars in that. Talk about the galaxy being oversized. Pretty hard to imagine that. Our sun would not even show up on that picture. Oh, and actually, what's cool about this, I took this picture during a supernova. Supernovas are pretty rare. They happen about every 100 to 1,000 years in our galaxy. But if you look at enough galaxies, you can see one every year probably, because there are thousands and thousands of galaxies out there. And this star right here wasn't there a week before I took that photo. And that's a supernova in that galaxy. So that was kind of cool to take that. Okay, so next one. Okay, this is another galaxy called the Sombrero Galaxy. And again, a lot of variety there. Our God is a God of variety, and that's pretty amazing. So next one. And that's another galaxy that's called M33. And the next one, that is called the Ring Nebula. The Ring Nebula is a supernova explosion that's leaving a bubble, and we're seeing the bubble, and the edges of the bubble we're looking through a lot of stuff, so those appear bright. Whereas the front, we can actually see through because you're only looking through a relatively thin part of the bubble. And that's, again, one that's visible probably, but with good eyes, which I didn't used to have. I'll have to try it again now with binoculars. And that's a summer constellation. So next, and this is a pair of galaxies that's it's right above the Big Dipper. And you can see one of them is this way and one of them is kind of face on to us. So that's pretty cool. And the next one, okay, this is called the Omega Galaxy, or Omega Nebula, and it's a star nursery, just like the Orion Nebula is. It's one of the better ones in the sky, and this is a summer object. Okay, next. And we're about done with these. And this is just what we call an open cluster, a part of the sky where there are millions of stars in one little area. They aren't necessarily in any kind of formation, but it's pretty cool and this is what, when you see the Milky Way, you guys have all seen the Milky Way, I hope. It's surprising how many of my students never have seen the Milky Way because they've lived in cities and it's never been anywhere dark enough that they could see it. And actually, I'll tell this story quickly. Let's see what time we're getting at. Anyway, the Milky Way is consisting of these stars and millions and millions and millions of them. And during the Northridge earthquake, the electricity was off in Los Angeles. And people were told not to sleep in their houses because their houses may be damaged and it could fall down. And so a bunch of people called the police department and said, there's a strange glow in the sky, because they had never seen the Milky Way. So anyway, that's impressive. Okay, next one. And this one is the last one, and this is one of my favorites. This is another supernova explosion called the Dumbbell Nebula, and you can kind of see the dumbbell shape, sort of. This is kind of like clouds. You know, people say, I see a puppy dog, I see a dragon. Well, the stars don't necessarily make any pattern, but people make up patterns and attribute them. So this is another one. Okay, so next. Okay, and so anyway, that was what Messier discovered. And I want to talk about this lady for just a little bit. She was a computer. Okay, how can a person be a computer? Well, back before there were what we call computers, computers were very, very smart people who could do math. And she worked for Harvard University and she was doing calculations, and she noticed a pattern in a certain kind of star called a Cepheid variable. Now, this is important you understand this. And what she said is these stars get brighter and dimmer and brighter and dimmer on a regular pattern, and their brightness corresponds to how long it takes them to go from high to low. And she made a chart and figured out if it takes 17 hours to go from its dimmest to its brightest, then this is how bright it intrinsically is. And astronomers use two different numbers or two different ways of describing how bright something is. They call apparent brightness, and that's how bright something appears to us. And then there's absolute brightness, which is how bright it would be if you were a set distance away. So for example, if I had a little flashlight and I held it right up in Frank's face, it would appear to be apparently pretty bright, right? But if I took it a half a mile away and shined it in your face, you could barely see it. And on the other hand, if I had that little flashlight and a searchlight next to each other, the searchlight, we could put it 20 miles away and the flashlight close. They might appear to both be the same brightness, but obviously the searchlight is intrinsically brighter. And if you know how intrinsically bright something is, and this is the key, you can calculate how far away it is. So if I tell you that light over there is the light from a 57 Ford, and you happen to know 57 Ford, you'd say, oh, I think it must be a half a mile away. And you could make that a pretty intelligent guess. And if you had scientific instruments, you could make a very precise guess. So she suddenly had a way of telling how far away things are based on the cycle of brightness to dimness for this particular type of star. Okay, so she discovered that in the 1850s and 1870s, and along came this guy, Edwin Hubble. You've all heard of him. And Hubble said, and up until this time, remember, all those fuzzy spots were considered to be part of the Milky Way. And Hubble happened to have the best telescope in the whole world. Some of you may have visited the Mount Wilson telescope above Pasadena in Los Angeles, which wasn't all smoggy and bright like it is now. It's a useless telescope at the moment, but at the time it was the best one in the world. And Hubble said, I'm going to take and point at one of those fuzzy spots called the Andromeda Galaxy and see if I see any of these Cepheid variables there. And he found some, and he did the calculation, and he says, that's not millions of light years away, that's not thousands of light years away, it's millions of light years away. So all of a sudden, the universe stopped being this size to being as large as this room. And we discovered that all these fuzzy patches were other islands of stars far out there, far, 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 far out there. And so he was the discoverer of the first one to discover the size of the universe that are within it. Okay, and then the next one here. And what he discovered, and this is something you guys have probably heard of called the Doppler effect. He didn't discover this, but he used it. The Doppler effect says when something's coming towards you, it's a higher frequency. When something's going away from you, it's a lower frequency. And if you've ever walked on the road and had people honk at you, you hear it go, wow, as you know the car passes you, because as it's coming towards you, it's a higher frequency, and as it goes away, it's a lower frequency. And what it means is, as things coming towards you, they're shifted to a higher frequency, and as they go away, they're shifted to a lower. Well, in terms of light, that means they appear to be more bluish when they're headed towards you, and they appear to be more reddish as they're passing away. And he discovered that, and he discovered that when he started looking at all these galaxies, that almost all of them were going away, that the universe seemed to be expanding. The universe seemed to be getting bigger as time was going on. And that was the genesis of the idea that most scientists today accept as an origin of the universe called the Big Bang. How many of you guys believe in the Big Bang? I didn't expect to see many hands. But let's talk about that for just a minute. The Big Bang says at one point, if everything's going away, what are you going to assume? At some point they were closer together, right? And if you follow that to its logical conclusion, at some point they were all in one place. And that was what he came to the conclusion. And he created what's called Hubble's law, where he could predict and figure out how far away something is based on how red-shifted it was. Okay, and so he concluded that the universe is much bigger than we imagined. Universal expansion that we observe implies that everything was closer in the past, and ultimately that led to the conclusion of there was a thing called the Big Bang. And I'm hoping at the end of today, and you guys may never talk to me again, and you may never like me again, but to convince you that the Big Bang isn't totally unreasonable, that it fits within, in the beginning, God. And we'll go there here in just a minute. Okay, so next, along came these two guys. These guys work for Bell Labs, and that thing behind them is a radio telescope. And they use that to look out into the universe and measure things, but it had a hum in it, and it drove them crazy. They went through all of their electronics trying to figure out what it was that was causing this hum. They even figured out that there were some pigeons that had taken up residence inside the horn of that thing. And so they hired a guy to come and shoot the pigeons. And whatever they did not get rid of the hum. And so they got calling around to other people who had radio telescopes and said, "Do you guys hear a hum?" And they said, "Yeah, we hear a hum." And it turns out that that hum wasn't something that was just created by the telescope, but it was something really out there. And it has come to be what we call the cosmic background radiation. Remember the Lone Ranger and Tonto? They'd be chasing some desperados, and they come up on the camp where the desperados were, and Tonto would get off the horse, put his hand down in the fire and say, "They were here 7 hours ago," or "They were here 2 days ago," based on how warm the fire still was, right? Because things don't instantly get cold when you turn them off. It takes them a while to cool down. And what they discovered is that everywhere you look in the universe, there's a remnant of heat left over from something. And it turns out that that remnant of heat is consistent with the idea of a big bang, of a big expansion that happened at one time. And that over the years, that has cooled down, but there's still some left, and it can be actually measured. And that's called the cosmic background radiation. These two guys got the Nobel Prize for that. Anyway, next. And then along came the 90s, and we launched the Hubble Space Telescope. It was a bust when we first put it up because they miscalculated it, and they had to go up and put contact lenses on it so it could see well. But by 1995, it was in shape, and the scientists said, let's take a picture, let's pick a spot where we think there isn't anything there, the size of a grain of sand held at arm's length, and let's focus on that for 11 straight days and see what we get. Well, this is what they got. So what are those? Kind of look like, some of them look like stars, but in reality, every one of those things is a galaxy. And so at that point, the universe went from being the size of this room to being the size of the world, and it just got infinitely larger. And we saw millions and millions and millions and millions of galaxies. So that was the Hubble Deep Field, which was in 1995, and it's been repeated several times since. And the exciting thing is the newest telescope that's supposed to go up at the end of October, I think it's supposed to be launched on Halloween, is called the James Webb, and it may be as much as 100 times as powerful as Hubble. So we're going to see some amazing stuff when that gets up there. So pretty amazing. Okay, so next. And the other thing that we need to understand about the universe is, and this is a very strong argument for us Christians, is what's called the fine-tuning argument. The fine-tuning argument says whenever you see something that is perfectly crafted, somebody had to make it. It doesn't happen by accident. Okay, you guys all know that. You're walking along a trail with a bunch of rough rocks, and all of a sudden you come across something that's perfectly smooth and round, and whatever you say, oh, I wonder what this was. Who left this here? You know that it didn't happen by accident. Well, the universe, we know in evolution that we are very, very fine-tuned. We wouldn't exist as humans unless we had just exactly the right chemicals and the right conditions. But the universe itself is fine-tuned to an amazing extent. And these are quotes, and I believe they're both by Stephen Hawking. Hawking is the man that had the cerebral palsy, that was one of the great thinkers, considered to be thinking on Einstein's level. And he says, if the state of the hot, dense matter immediately after the Big Bang had been ever so slightly different, then the universe would either have been rapidly recollapsed or would have expanded far too quickly into a chilling, eternal void. Either way, there would have been no structure in the universe in the form of stars and galaxies. And the amount it would have had to deviate is less than 1/1000th of 1%. So if that was just slightly different, the universe couldn't exist. Well, what's the chances that that could happen exactly that way? You know, I've been thinking about these fires that we're having right now and how fortunate we are to have just the right percentage of oxygen in our atmosphere. If we had 30% oxygen instead of 21% oxygen, how violent would these fires be? And, you know, God gave us just exactly the right things that we need. And when we look at the universe, we find out that it's finely tuned as well. There are 4 what they call fundamental forces, and some of them you're familiar with: electromagnetism, gravity. Another one is what they call the strong and the weak nuclear force that hold atoms together. If any of those had been slightly different, the universe wouldn't have the structure it has today. It wouldn't have any structure. It couldn't exist. And yet, those were all formed theoretically in that first fraction of a second when the universe came into being. Okay, so what problem does this create for scientists when they try to explain or try to prove a Big Bang? Let's go to the next one. And a couple of, well, actually, I'll talk about the problems for scientists in a second. So there was a distinct beginning, and we as Christians believe that. The Bible says, in the beginning. We believe there was a distinct beginning. So does the Big Bang. It says there was a distinct time when nothing existed, and now it did. We have an explanation for that beginning. And the theory says that the Big Bang wasn't the creation of matter inside space. There wasn't all this space into this little blob of mass floating around that expanded. That little mass was everything there was. There was no time before that. There was no space before that. That was the beginning of time and space and everything. Okay, now that fits into our idea of God, that God is outside of time and space. God is beyond time and space. And that's what the Big Bang seems to be saying, that there is something outside of time and space that created this happening. And then finally, the fine-tuning we observe is only explainable by an omnipotent creator. So, amazing, perfection here that can only be explained by God. Okay, so the next one. So why a lot of scientists, and I actually saw an article on this today, a lot of scientists have a really hard time with the Big Bang because, number one, it doesn't explain how this fine-tuning could have possibly happened. And they have no explanation for what happened the second before the Big Bang. How could something be created out of nothing? And yet that's what the Big Bang seems to say. Well, Christians, we don't have a problem with either one of those. You know, we believe that there was a beginning. We believe that something outside of time and space created that beginning. And we believe that he fine-tuned those little guys. They made those things exactly right so that the universe could exist and so we could exist. And he did that perfectly. He did that for us. So we have no problem with that. And you'll hear some various attempts to explain this. The current one that everybody loves is called the multiverse. You guys ever heard of a multiverse? Well, a multiverse is there's an infinite number of universes out there, and we're just one of them. But we happen to be the one that got it right. All these other ones had different values for these things, and they didn't form into what we are, but we happen to be the lucky ones. So we are here. And the problem with the multiverse is there's no evidence for it. It's just a way to try to explain the unexplainable from their point of view. So that's an attempt to try to explain how something could come from nothing or something could happen. And then I heard today somebody was talking about an oscillating universe, that the universe eventually would expand to the point where it all gets eaten up by black holes, and then it would start all over again. And we're the 900 billion 337,1,213th iteration of that happened to get it right. So anyway, those are explained, but they have a hard time. They can explain what happened at various points, but they can't explain what happened at that beginning. And we believe that there is a God who is outside of the universe, who is able to create the universe. So pretty amazing stuff. Okay, so next one. And I just want to talk about this very, very briefly. The elephant in the room. Okay, as Christians, we've been taught, a lot of us have been taught that the earth is young, that the earth is not very old. And this model pretty much implies that it's not young, that it is relatively old. Now, the way I deal with my students is say, there's two possibilities here. God, it could be old. That's one possibility. The other possibility is God could have made it to look old. And the example of that is Adam. Was Adam created as a baby? No, he was probably created as a grown man. Did he have a belly button? Yeah, probably. And yet he was only 1 day old, but he looked like a 30-year-old man. Well, God could have created the universe and made it look old. So I don't know. And to some extent, I don't care. Because arguing the age of the universe is a dead issue for us. It's an issue that's a losing issue. I was talking to Albert before, and he was talking about his son-in-law who had lost any faith in God, and that he was trying to convince him, of God, by talking about what's wrong with evolution. And it turns out that if you want to lose that argument with somebody who doesn't believe in God, you start out by saying, the earth is only 6,000 years old. What happens when you say that? Yep, and the earth is flat, and the Easter bunny steals people's teeth. I don't know. You're immediately dismissed. So even if you believe that, don't lead with that. What do you lead with? Fine-tuning. Fine-tuning is a very strong argument. The whole argument that we have a perfectly crafted universe, and that the only way it could get that way is if something outside of it was guiding that, was making it happen. That's a strong argument. So that's where you go. Okay, so don't get hung up on the age. Okay, I don't think it's a matter of faith. I don't think God's going to say, "Oops, you got it wrong." Hell, I don't think that's going to happen. But I do know that if you lead with that with some of your non-Christian friends, you've lost the argument in the first 30 seconds. So don't go there. I would highly recommend that. Okay, so let's go on for just quickly. Okay, I want to talk about, and this is just an advertisement, will be done in 3 minutes. You know that we have a world-class, amazing observatory in Placerville. And it's open right now every Saturday night. I'm a docent there, so if you come while I'm there, I'll be happy to show you around. But we have some amazing telescopes, and we have what's called a sky theater, which is a round amphitheater where you sit up and look at the sky and can see some amazing stuff. We have 3 really big, beautiful telescopes that you can look through, that you'll see some things similar to what I was showing you there with my pictures. And it's free. It's a great date night, guys. It's a good place. I tell that to my students. They like it maybe more than you guys do. But anyway, so just a couple more slides. Let's go to the next one. This is just a picture. That building behind there, actually the roof slides off. And there's 2 big telescopes inside there. And this was funded by the Rotary Club of Cameron Park. Was the ones who started this in 2008. And it's become quite a place. And it's one of only 2 privately run observatories in California where the public can go. It is behind the community college on the corner where Missouri Flat and Cold Springs come together, right there. And there's a big sign. And you can look it up. And if you go, you should look online first to make sure it's going to be open, because lately we've had quite a few smoke closures. I'm hoping for this Saturday night, and I'll be there. But anyway, that's pretty cool. Next, that's one of our 16-inch scopes, which is marvelous. Looking through that, you can see some amazing things. Okay, next. And this is the Sky Theater. I usually lecture there and show people the sky, and we all have red lights so your eyes become dark adapted. Very, very cool. Okay, and next. That's it. Okay. So anyway, I hope you guys still like me. Anyway, I appreciate you guys. Thank you very much.